This is Excel for Physics, a video series describing how to use Microsoft Excel to solve common physics problems. Lesson 1 is describing a triangle. So assume you're given 3 points described by their coordinates on the XY plane. Connect those points with lines and you have a triangle. We'll go ahead and label those points A, B, and C. So moving over to Excel, we have 2 points of data about each of the points on the XY plane. We have, for each point on the plane, we have an X coordinate and a Y coordinate. So you're going to start by creating 6 labeled boxes, AX, AY, BX, BY, CX, and CY, to describe the 3 points. Fill those in with the coordinates that you're given for each point, simply by typing a number in the adjacent cell and hitting enter. Next, we'll go ahead and label the lines that are connecting the points as AB, AC, and BC. For a minute, let's just consider one of the lines, AB, that runs from 0,4 to 3,0. Now we want to find the slope of this line, which you probably learned in algebra or possibly geometry. The slope of a line is equal to the change in y over the change in x, or dy over dx. So again, to determine the slope of a line, we need 2 pieces of data. The change in x over the length of the line and the change of y over the length of the line. So to determine the slopes of the 3 lines, we start by putting dx and dy for each of the 3 points, or each of the 3 lines rather. And considering line AB, the change in x is the difference between the x coordinate of B and the x coordinate of A. So you're going to use your first formula, type on the box next to dxAB, and type equals, which is the sign that you're going to start a function in Excel, or a formula rather. And then click on D1, which is where the x coordinate for your point B is stored, and then minus sign, and then the cell where your x coordinate for the point A is stored, and hit return. And this will give you the change in x between points A and B. And then you go to dyAB, which describes the change in y between points B and A. And you'll do something similar. You put in an equal sign, and then D2, which is where the y coordinate for point B is, minus B2, the y coordinate for point A. So your formula will be equals D2 minus B2, and hit enter. And then you do similar things, similar formulas for dxAC, dyac, dxBC, and dybC. And now you know the changes in x and y between all 3 points. So looking back, you know, the slope is equal to dy over dx. So we'll use that knowledge to calculate the slopes for lines AB, AC, and BC. Create label cells, and then the formula for determining the slope is just dy over dx. So to find the slope of line AB, we're going to type in the formula equals B5 divided by B4, which is equivalent to dyAB over dxAB. When you hit return, that gives you the slope of line AB. If you do similar formulas for the slopes of AC and BC, you'll get extraordinary results. The slope of AC, because it's a purely vertical line, means that the slope is calculated by dividing by 0, which is undefined, and Excel will give you an error. Don't worry about that error. You know what it is, and it knows what it is, so there's no problem there. And the slope of BC, because it's a purely horizontal line, is equal to 0. So next we're going to go to calculating the lengths of these lines. And if you recall the Pythagorean theorem, AB squared equals AC squared plus BC squared. And then when you turn that around and solve for AB, you get AB is equal to the square root of AC squared plus BC squared. So to represent that in Excel, again, create your label cells. You're describing the line, so just use AB, AC, BC, and this is assumed to be the length. And the formula you're going to use involves the square root function. So the abbreviation for square root in Excel is SQRT, or squirt. So you're going to enter equals SQRT, left parenthesis, B4 caret 2, right parenthesis, plus left parenthesis, B5 caret 2, right parenthesis. So you've got a couple different things going on here. The square root is obviously, the square root function finds the square root of whatever you give it as an argument. In this case, the argument is the numbers falling between the first and last parentheses in this formula. And then the caret is the way that Excel does exponents. So by saying B4 caret 2, you're getting B4 squared. And because you're adding those two squares and then finding the square root, you're effectively finding the value of AB. So type in that formula, make sure it's referencing the correct slopes, or rather, not slopes, but delta x and delta y. And hit enter, and you should come out with the length of the line AB, and repeat the same things for AC and BC, and should come out with 3 and 4. You already knew this was going to happen because just looking at the coordinates, you can see the lengths of AC and BC. And if you know the Pythagorean theorem, AB has to be 5. But now you know how to do it in Excel. So I hope you find that useful, and next time I'll try to cover some trig functions, which come in very handy for a lot of physics. Thanks for watching. Bye.